Where can you find the Fibonacci sequence inside Pascal's triangle? Imagine a triangle made of numbers that grows row by row, each number built from the ones above it. This is Pascal's triangle, a simple yet mysterious pattern in mathematics. Now, picture a sequence of numbers that keeps adding the last two to get the next. That is the Fibonacci sequence. You might wonder how these two are connected. Well, the secret lies in the diagonals of Pascal's triangle. If you look at Pascal's triangle from the left edge and follow the shallow diagonals, you will see something amazing. When you add up the numbers along these diagonals, the totals from the Fibonacci sequence. For example, start at the very edge where all the numbers are 1. The first diagonal has just 1. The next diagonal contains the numbers 1, 1, 2, 3, 5, 8, and so on. These are exactly the Fibonacci numbers. This pattern happens because each Fibonacci number can be written as a sum of binomial coefficients, which are the numbers in Pascal's triangle. When you add the numbers along these diagonals, you are essentially summing the binomial coefficients that make up the Fibonacci sequence. It is like uncovering a hidden code inside the triangle. You can visualize this by imagining Pascal's triangle as a right-angled shape and adding the numbers along the diagonals from the left side. The sums match the Fibonacci numbers perfectly. The first diagonal sums to 1, the second to 1, the third to 2, the fourth to 3, the fifth to 5, and so on. This neat connection shows how different patterns in math are often linked in surprising ways. This relationship between Pascal's triangle and the Fibonacci sequence is more than just a coincidence. It reveals how simple structures can encode complex sequences. It also helps in understanding how numbers grow and connect in nature and mathematics. For example, Fibonacci numbers appear in flower petal arrangements, shells, and even in the branching of trees. Knowing where to find the Fibonacci sequence inside Pascal's triangle makes the triangle even more fascinating. It shows how a basic pattern of numbers can hide a sequence that appears everywhere in the natural world. Summing the numbers along the shallow diagonals of Pascal's triangle is a fun way to see this beautiful link in action. It reminds us that math is full of hidden relationships waiting to be discovered.